Hello everyone, we present Voxify3D, pixel art meet volumetric rendering. This work is done by Yichen Huang, Jiewen Chen, Haozhen Chen, and Yuwen Liu from National Yangming Chiao Tung University. Voxel art is widely used in games, animation, and digital media. However, generating high-quality voxel art from 3D objects remains challenging. Existing methods often lose important semantic structure, produce blurry geometry, or fail to preserve clean voxel aesthetics. In contrast, Voxify3D converts 3D images into expressive voxel art while preserving important semantic details and style abstraction. One key advantage of our method is controllable stylization. Users can flexibly adjust voxel resolution, palette extraction strategy, and color quantity to create diverse voxel art style. Existing voxelization methods still suffer from several limitations. Some methods generate noisy or inconsistency voxel structure, others fail to preserve important semantic features such as facial details or object articulation. Simple procedural voxelization often lose expressive appearance information and produce overly coarse results. As shown here, prior methods frequently generate blurry geometry or unstable stylization artifacts. Our work is motivated by the observation that pixel art is fundamentally different from traditional pixel downsampling. Compared with nearest neighbor downsampling, pixel art preserves cleaner, abstract edge and more expressive style structure. Therefore, instead of directly simplifying geometry, we use pixel art as the supervision signal for voxel optimization. However, directly applying pixel art supervision introduces another challenge. Traditional perspective rendering causes pixel to voxel misalignment because rays are not parallel. This leads to blurry optimization gradients and unstable voxel stylization. To address this issue, we adopt orthographic rendering. Since the orthographic rays are parallel, voxel location align precisely with pixel art supervision, enabling stable style voxel optimization. Our framework consists of two stages. In stage 1, we first optimize a coarse voxel radiant field using DVGO. Unlike nerve methods based on NLPs, DVGO directly optimizes explicit voxel brief for density and color. This stage establishes the initial geometry and appearance representation of the object through multi-view rendering supervision. In stage 2, we refine the voxel representation using orthography pixel art supervision. We first generate 6 canonical view pixel art images from the input object. Then, the voxel grid is optimized using multiple supervision signals, including pixel loss, depth loss, alpha loss, and clip loss. One key component of stage 2 is our patch-based clip guide optimization. Instead of computing clip loss over the entire image, we randomly sample local patches during training. This helps preserve semantic structure under extreme discretization, such as facial features and the object identity. The clip loss encourages semantic consistency while still maintaining style abstraction. Another important component is differentiable palette quantization using dumbbell softmax. Instead of directly predicting RGB values, each voxel predicts logics over a predefined color palette. During training, we add random dumbbell noise to the color logics to construct noisy logics. These noisy logics are then passed through a temperature control softmax to produce differentiable discrete color probabilities. This allows the model to perform discrete color selection while still remaining fully differentiable for end-to-end optimization. By combining orthographic supervision, semantic-aware optimization, and differentiable palette quantization, Voxify3D generates expressive voxel art with both abstract aesthetic and semantic fidelity. We compare our methods with several existing approaches. Compared with differentiable editing methods and procedural voxelization approaches, our method better preserves semantic structure while generating cleaner voxel abstraction. Existing methods often produce noisy detail, blurry structure, or unstable stylization artifacts. In contrast, Voxify3D achieves more coherent abstraction with clearer voxel boundaries and stronger semantic consistency. We further evaluate our method using the CLIP IQA framework, which measures semantic consistency between voxel rendering and texture descriptions. Average over 35 examples, Voxify3D achieved the best score among all compared methods. We also conduct a user study with 72 participants evaluating visual appeal, abstraction quality, and geometry preservation. Voxify3D is consistently preferred over existing methods across all evaluation categories. Finally, we conduct an additional color quantization study with 10 participants without related background. The results show that Gumbel mass produce cleaner voxel boundaries and more visual coherent color regions, leading to a strong user preference over continuous color optimization. Here we demonstrate voxel art generate using different palette extraction strategies. Different palette methods produce unique color clustering behaviors and stylization aesthetics while still preserving consistent voxel structure. We also analyze the effect of different palette size. Smaller palettes lead to stronger abstraction, while larger palettes preserve richer visual detail and color variation. Different voxel resolution further provide flexible control over abstraction and geometry detail. Lower resolution emphasize style abstraction, while higher resolution preserve finer semantic structures. Beyond digital stylization, our method also demonstrates strong fabrication potential. Since Voxify3D produces discrete voxel structure with compact color palettes, the generated result naturally align with physical assembling applications such as Lego styles construction. This opens up exciting possibilities for physical toy design, 3D printing, and voxel-based creative workflows. In summary, Voxify3D bridge pixel art supervision and volumetric rendering for style voxel art generation. Build your imagination in voxels. Thank you for watching.